Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aisyah Nadira binti Murad. My group member is Nur Maisara Ilyana binti Muhammad Rahim and Dr. Wan Munira binti Wan Muhammad. I will present for the Joe International Innovation Invention Competition and Symposium 2025 with the title GUI-based Logic Fuzzy System for Efficient Student Selection in SPP Malaysia.
Let's move on to introduction. Sekolah Berasrama Penuh (SPP) is a prestigious part of the country educational system known for its dedication to academic performance and nurturing the potential of bright students all throughout the nation. Determining qualified applicants from a large pool is very challenging and time-consuming. Therefore, it is often entangled with uncertainty, lack of transparency, and unfairness. In response to this issue, this project developed a fuzzy logic-based system that can change the SPP selection process. Now, let's move on to problem statement and objective. The first problem statement is time-consuming, where manual evaluation of a large number of applicants is inefficient. Next is subjectivity, where human judgment can be biased and inconsistent. And the last problem statement is difficulty in handling multiple factors, where assessing a variety of criteria can be complex. The selection process frequently suffers several delays, lowering its overall efficacy. As for the objective, the first objective is to increase the timeliness of the SPP program student selection procedure in Malaysia. The second one is to provide standards inside the fuzzy logic framework that guarantees student selection is fair by taking into account a variety of variables. And the last objective is to enable the GUI to handle multiple selection criteria using fuzzy logic, allowing for a comprehensive selection process. Next is scope and limitation. As for scope, the first one is focused on selecting the right candidates by evaluating multiple criteria using fuzzy logic. Next is to utilize MATLAB fuzzy logic toolbox to define membership function, to create fuzzy roles, and to develop graphical user interface, which is known as GUI. As for the limitation, the first one is complexity in fuzzy logic design, and the second one is to define the membership function, and fuzzy roles require significant time, expertise, and effort for optimal system performance. And this is the flowchart for methodology. The first step for research methodology is determination of data input. For the student selection tool, data input refer to the criteria we use to evaluate each student's qualification. Some criteria that have been taken into account are academic, leadership, and co-curricular activities. The first data input is academic performance. In academic performance, there are two main aspects that has been taken into account, which the first one is PBD, problem-based learning, and also exam score. As for PBD, there are 6 different levels, which the first one is TP1, followed by TP2, TP3, TP4, TP5, and TP6. The second data input is leadership, which the total score range is from 0 to 30 with the respected position. And the last data input is co-curricular activity, where the total score range is from 0 to 20 with the respected levels and participation score. The second step is determination of data output, where data output is the final decision or recommendation for each student based on their score across key criteria. The possible outputs are accepted, to be considered, and dismissed with the respected score. This is the list of equation used, where the first one is for academic, followed by for the leadership, for co-curricular activity, and the last one is used for centroid calculation. The third step for research methodology is implementation of fuzzy logic tools. Fuzzy logic is used to evaluate student score across different criteria and to handle cases where score may not perfectly fit into yes or no categories. There are few steps on how to implement fuzzy logic, where the first one is define membership function, second one is to create if there are rules, and the last one is reasoning process or rule viewer. The first step is to define membership function for each variables. The membership function editor is an important tool in fuzzy logic system, enabling user to define and edit the membership function that quantify the degree of truth in input values. In this project, trapezoidal membership function is used in this research. And the figure shown is membership function for each variables. Next is creating if-then rules. If-then rules provide an easy-to-use interface for establishing and maintaining the rules that guide the system decision-making procedure. By defining the logical relationship between input variables and their matching outputs, user may make sure that fuzzy system meets the intended criteria. A total of 27 rules have been set up for the student selection procedure. It has been carefully designed to evaluate different factors that are essential for the SPP program, and these are 3 out of 27 rules that have been created. Next is reasoning process. The reasoning process goes through 27 rules which have been created in the previous process. User may be able to understand how fuzzy logic is by using the rule viewer. The fourth step in research methodology is implementation of GUI, Graphical User Interface. The GUI in this project is designed to make the student selection system easy to use, letting user to input the data and view selection result without needing to work directly with code. And there are few basic tasks, which the first one is laying out GUI components and programming the GUI components. And for the key elements is component, figures, and also callback. This is the layout design of GUI, where you can see the above part is student information, the middle part is the scoring section, and the last one is result section. The fifth step is app development. Once an applicants have been finalized and all requirements have been met, deployment will be the final step, suitable to the objective of which to identify and select a pool of students who are best suited for admission to SBP based on their fit to the intended criteria. I name the apps as future fits. With academic performance weight at 40.6, leadership at 18.3 and co-curricular at 8.2, the cumulative score for applicants total is 88.5. Therefore, consequently, based on this score, the system categorized the candidate result as accepted. And this is the dummy result of 3 students, where for student A, the selection result is accepted, student B, the result is to be considered, and student C, the result is dismissed. Therefore, in conclusion, I can say that this project successfully implement a fuzzy logic system via MATLAB GUI to ensure fairness, transparency, and efficacy in SPP student selection. It demonstrates the usefulness of fuzzy logic system in decision-making process.